Before you watch this video, thank you to all your subscribers for this 250 subs. I'm happy. So now I could make better videos than ever. But the only one slight problem is that I'm like running out of content. But still, I can make better videos. But I'll just make videos a little like longer. Like each video will be like 1 week or 4 months. Okay, because I'm running out of content. Okay, so now you can watch the video. Hi, you viewers who are just watching this video. I think you know what did you even just clicked. And yes, I am going to say all the 118 elements. Yeah, for sure. And all of those walls you see, I think you will see here, those will cover with other atoms. And somehow I think like atoms configuration things will just jump on me, like jump on my head. I don't know, but my editor will help me. Okay. So you know abundance, right? And if you don't know abundance, just click out of this video and just search abundance. But just don't click. I'll just say a short definition for abundance. Abundance just means like how much is there. And I think you know what you have clicked. So So our first element is hydrogen. Hydrogen with 75%. And I'll explain you why. I know some space things. So also I'll just read off this green thing. Just ignore that. Okay. I'll just explain to you why hydrogen is the most abundant element. Because I read lots of books about space, so I know. Because this is about universe. Also, just pretend that this pencil is a mic. Okay. Also, I'll just edit this pencil as mic. Okay. Hydrogen with 75%. It is because of at the starting of Big Bang. Lots of electrons, protons, neutrons all came out. Then after the Big Bang, all those electrons and protons were swirling and sometimes even combining. So in 7 days, about 7 days after the Big Bang, we have made hydrogen and sometimes deuterium. And if you don't know deuterium, it's just only one neutron, one electron, and one proton. But hydrogen has only one neutron and one electron. Okay? I think no proton. If I have made any mistake, it will be at the top of the screen, okay? Okay. And it also made helium, where all the stars produce their fuel. Like 2 hydrogen combined into helium. And I said deuterium, right? I think it's I know it's 1 in a hundred of hydrogen atoms is deuterium. But now all of those deuterium has been used up, so yeah, it's quite low. Okay, so the next one, which is the second, is helium. And yeah, you already know why helium. With 24 to 23%, yeah, there's two numbers. I think you will mostly read that it has 24%, but sometimes it's 23 because its actual percentage is 23.0, but sometimes you'll be 24. So yeah, that's why I included two numbers for this element. And I think you know why helium, because of the Big Bang, stars, nebula, galaxy. It's everywhere. All the stars produce it. I'll also put up here that where will this element come from. Okay, so next is oxygen with only 1%. Remember, it is approximated. That's why I'm saying it all in full numbers, in whole numbers. And sadly oxygen is the only element which has only whole numbers. Only hydrogen, helium and oxygen has that 1s, 10s, 100 place, and rest of those you'll see in decimal percentage, I mean. Okay, also you'll say, why oxygen? How is oxygen 1% of this universe? And I'll say you this. While I was researching this, I saw that oxygen actually came from the death of stars, because I know and I read about stars. If they run out of hydrogen, they'll use helium and some heavier element, combination of helium to make a heavier element carbon. Okay, two helium combined into carbon, then two carbon produces oxygen. It's like that. Okay, then two oxygen gives magnesium or neon. Okay, so while the death of the star, when the death of the star is approaching, its fuel is heavier elements. Okay, but it's not that much common because stars has lots of hydrogen, then some helium, then some carbon, then some oxygen, so it just keeps reducing. Okay, so the next one, the next element is the thing that we're polluting the earth in, that also makes life, which is carbon. Because carbon dioxide, carbon monoxide, carbon, you will hear carbon dioxide. Even in life, without carbon, there's no starch, photosynthesis. There's no complex arrangement. We can't make us. We can only, without carbon, there's no life, because carbon has the right amount of valency and abundance, and half-life that carbon is stable, its valence is 4 and all of those, and carbon's percentage is 0.5 in the universe, because carbon, like I said, two hydrogen gives us helium, two helium gives us carbon, or maybe boron, but in one point of its life it will give carbon. Okay, so the next one is neon. I was surprised. And it is also mostly death of stars. So it's only 0.13%. It's not 13, not 0.13. It's 0.13%. And that's all. Next is iron, which is 0.11%. And iron is the fifth top of this element of abundance in the universe, because iron stops the stars. Stars use nuclear fission and we use nuclear fusion. Both of those stop in iron, because those two are stable. Because if you're making the end of the star produces 2 magnesium, gives iron. Okay, that's the end. Okay, so iron is the most stable element, which just stops nuclear fission and fusion. Okay, so that's why stars die, because after iron is absolutely stable. If you give heat, it can't produce new elements. Okay, that's why. Next is nitrogen. About 70% of our air is nitrogen, which is in the universe is 0.1%. Okay. So next is silicon with 0.07%, and it's also mostly dying of stars. Even nitrogen. Next is magnesium, which is only 0.08 and 89%, because 2 magnesium gives us iron. So sometimes the magnesium can't be used for nuclear fusion, because there's low amount of magnesium that it will explode. The star will itself explode. Okay, so next is sulfur, which is 0.07%. I don't know what to say, but it's also dying of stars. Next is argon with 0.02%. It is mostly used to stable stars, so it won't burst out when a nuclear fusion is produced. Okay, it might be. Okay, just remember, I'll put all the mistakes what I've made up here. Next is calcium with 0.007%. That's the first one with 3 zeros, because 0.00 7 percentage. Okay, so next is nickel, which is 0.006 percentage, also from dying stars. Next is next is the element which both American English and British English differ, which is aluminium. R for your American is aluminum. With 0.005 percentage. It's also dying of stars. Mostly like it might be aluminium plus aluminum just gives us like magnesium. Okay. Next is like sodium, which is 0.002 percentage. And I don't know what to say about this. Okay. But next is chromium, which is 0.0015 percentage. Okay, 0.0015 percentage. That's chromium. And for sure, I know that Chrome did not invent chromium. For sure. Okay, so next is manganese. The most confusing one, I think, which is 0.0008 percentage, because most people like confuse like magnesium and manganese. Okay, it's like gonna be like top 1 or top 2, because there's still another one that some people also confuse. So next is phosphorus. Yes, not potassium, because some like be confused with phosphorus and potassium. It is 0.007, and if you don't know phosphorus, it's the element which is like in the matchsticks. Like when you like strike a matchstick in a match box, it will fire, right? It will lit up. It's because of that phosphorus, that red dot, I think you will see. Next is cobalt, which is 0.0003 percentage. 0.303. Okay. So I think I should use like scientific exponential something, but for now I'll use this. Okay, next is titanium. It's not titanium, it's titanium. It's 0.003 percentage. And you'll say, hey, cobalt and titanium are both like 0.0003 percentage. And I'll say that it's approximated. Okay, we can't fit like lots of decimal places, or this will be a like long video. Okay, so next is potassium, which is again 0.003 percentage. Next is vanadium, which is 0.001 percentage. And I said titanium, right? That's like titanium and tungsten. Sometimes they'll get confused. Okay, so next is chlorine with 0.001 percentage. Next is fluorine with 0.00004 percentage. then it's zinc with 0.0003%, which is like 0.4 zeros and 3. Then germanium, the last one with having like that decimal thing, because next we need scientific exponential something, because I can't say a whole amount of zeros here, okay? So germanium is 0.0002, 4 zeros and 2, okay? So next is copper, which is 6 times 10 to the power of minus 6%. And if you don't understand, it's just 0.000006. 6 zeros in the decimal place. Don't count that one place once. Okay, I think you will know like scientific exponential or something else. So next is zirconium, which is 5 times 10 to the power of minus 6%. Strontium, which is 4 times 10 to the power of minus 6%. Krypton, which is 4 to the power of 4 times 10 to the power of minus 6%. Selenium, which is 3 times 10 to the power of minus 6%. Scandium with 3 times 10 to the power of minus 6%. Lead, which is 1 times 10 to the power of minus 6%. And yeah, we have a whole list of ones which I can say again and again and again. Yeah, my mouth is like dry now. So after lead, it's neodymium, cerium, barium, xenon, rubidium. Which is actually my favorite element because it's the 37th one. Gallium, and yeah, and all of those are 1 times 10 to the power of minus 6%. Okay, and I set it all in all order. That means after lead is neodymium, after neodymium like that, okay? Just to remember. Next is tellurium. With 9 times 10 to the minus 7%. Next is arsenic with 8 times 10 to the power of minus 7%. And yeah. Okay, so next is yttrium with 7 times 10 to the power of minus 7. Bromine with 7 times 10 to the power of minus 7%. Lithium, yeah, the third element, which is 6 times 10 to the power of minus 7%. Platinum, which is 5 times 10 to the power of minus 7%. Samarium is 5 times 10 to the power of minus 7%. Molybdenum, molybdenum with 5 times 10 to the power of minus 7%. Tin with 4 times 10 to the power of minus 7%. Ruthenium with 4 times 10 to the power of minus 7%. Osmium with 3 times 10 to the power of minus 7%. Yeah, next is iridium, iridium, dysтербиum. Oh my god, those are complicated names. Gadolinium, cadmium, I'll just I think I'll just type those names up here. Dysprosium, gadolinium, praseodymium, lanthanum, cadmium, palladium. All of those, with niobium. Okay, sorry. Okay, all of those are 2 times 10 to the power of minus 7 percentage. Next is mercury, iodine, boron, beryllium. It's all 1 times 10 to the power of minus 7 percentage. I'm just getting bored. Next. Cesium is 8 times 10 to the power of minus 8 percentage. Bismuth, hafnium, both are 7 times 10 to the power of minus 8 percentage. Gold, silver, rhodium are 6 times 10 to the power of minus 8 percentage. Thallium, tungsten, holmium, terbium and europium, not from Europe, I hope. I think it just rhymed. All are 5 times 10 to the power of minus 8 percentage. Thorium and anionium, both are 4 times 10 to the power of minus 8 percentage. Indium is 3 times 10 to the power of minus 8 percentage. Uranium and rhenium is 2 times 10 to the power of minus 8 percentage. I think I just copied. Okay. Lutetium, thulium, and tantalum. Tantalum is 8 times 10 to the power of minus 9 percentage. Actually, it is the last. It is the most uncommon one. And above those are lutetium and thulium, which both are 1 times 10 to the power of minus 8 percentage.